Hello, and welcome to Empowered Learning. This particular lesson will be on how to solve systems of linear equations by graphing the equations. So when we solve for a system of linear equations, what we're actually trying to do is just find out where those two or more lines intersect. And so when we deal with intersecting lines, we have three different outcomes that we're looking at. The first outcome is when we have two lines that intersect each other at exactly one point. So we have a line that looks like this, and then let's say another line that may look like this. Then at this point here is where they intersect. And so this happens when, of course, if we call this line 1 and call this line 2, this happens when the slope of line 1 is different from the slope of line 2. And so one of the things that we can do when looking at systems of linear equations is to figure out what the slopes of each of the lines are. And in doing it that way, we'll know whether the system will have exactly one answer or not by seeing if the slopes are different. So another outcome that we would have is in the case of when we have two lines that intersect at infinitely many points. And so what that looks like is two lines that are written in a system, but even though those lines look different, they are exactly the same line. Okay, and so what would happen in this case is you would have one line, if you graphed it, that would look like this, and then you would have another line that would shoot straight through it. So the other line would come through exactly like this. And so since both lines have the same points, they're going to intersect at every point. When we see a situation like this, we call this type of system a dependent system, meaning that in order for us to figure out the points for the possible solutions to the system, we're either going to have to plug in an x value or a y value so that we can find either or. If we plug in an x value, then that means we'll find the corresponding y value. If we plug in a y value, that means we could find the corresponding x value. And so, algebraically speaking, an example of what it would look like when two lines look different but are the same is this example that I have here. And so we see that we have 3x plus 3y equals 6 and y equals negative x plus 2. So we can see that these two lines are the same thing by taking this line, which is in standard form, and translating it into slope-intercept form. And so I'll come over here and do that on the side here. So we have 3x plus 3y equals 6. One way that we could translate this is just by solving for y. And if we do that, then of course, first thing we could do is subtract both sides by 3x. And then that cancels to 0, and we just have 3y equals minus 3x plus 6. And then we divide both sides of our equation by 3. And of course, if we get that, then we just have y on the left side because these 3's reduce to 1. And here we have negative 3x over 3 plus 6 over 3. And of course, negative 3 over 3 is just a negative 1, and we write it as just negative x for short. And 6 divided by 3 is 2. And you see that we have the same thing. Okay. Another thing that I want to mention is we could also get to this y equals negative x plus 2 quicker by translating what we know about the standard form of an equation of a line as far as what its slope and its y-intercept is. So you see I have removed the previous work that I've done so that I could rework this and show you it in another way. So we're going to start off again with the 3x plus 3y equals 6. And so instead of solving for y here, we're going to note that for an equation that is in standard form, we know that we can get the slope by doing minus a over b, where a is the number next to the x, b is the number next to the y, and we could find the y-intercept by doing c divided by b, where c is the number by itself over here and b is the number next to the y. So if we did that, of course, our slope is minus a, which is 3, divided by b, which is also 3, and we get a negative 1. We see that our y-intercept, of course, let me put that here, will be c divided by b. So c is the number 6, and b, again, is that number 3. So we get 2. And so now knowing that, we could put this in the slope-intercept form, and y is negative x plus 2. And to be more clear here, notice that our slope is a negative 1. So really what this could have been was a negative 1. Now I'll go ahead and draw 1 right here. Negative 1 times x. And that gives us the negative x plus 2 here. So that's how we got the negative there. All right, so saying all this to say that we can use what we know about the standard form of an equation of a line to see if our lines have the same slope and or same y-intercept. If they do have the same slope and the same y-intercept, then they are essentially the same line, and we're going to have infinitely many solutions. So what that means to us in terms of graphing is we only really have to graph one line, since they're both the same line. So to recap here, whenever we solve a system of linear equations, we're expecting 3 different outcomes, or 3 different types of solutions. The first type is the 2 lines intersect at exactly one point, and we know that that happens because the slope is different for each line. Second choice, which we just got through going over, is that the 2 lines intersect at infinitely many points, meaning that both lines that we're looking at are exactly the same line, they're just written in a different way. And we've also talked about how to look at the standard form of an equation of a line to be able to find out its slope and y-intercept. And so this is key for us to be able to figure out what our solutions are going to look like for our system, as well as is going to help us in actually graphing. And so we're going to talk about that here in a little while as well. So let's move on to case number 3. So case number 3 is when the lines do not intersect at all. So when we have a situation like that, essentially what is happening is that the lines are parallel to one another. So we would have a line that will do like this, and then another one that would be parallel to it. Of course, in this case, the slopes are the same, but their y-intercepts are different. So y-int of 1 does not equal y-int of 2. And so if we put this on a Cartesian plane, we would see that, for instance, this particular line would have a y-intercept of 2, whereas this one may have a y-intercept of negative 2. And so I'll go ahead and draw you a more clear picture so you can see how that looks. All right, so I'll remove the 2 previous lines so that I could draw one for you. So here we have a situation where one of our lines has a y-intercept of, let's say, 2, and our other line, having the same slope, would have a y-intercept of negative 2. And of course, these 2 lines are parallel, they will never cross. And since they don't cross here, then that means they will have no solution. Okay? So now what we're going to do is actually get into some examples of systems of linear equations and how to go about solving. Okay, so now we have our first example, and we have a system of linear equations where both equations are in standard form, and what we want to do is graph them. And through graphing them, we want to find the point where they both intersect. And wherever that point is will be the solution to this particular system. So the approach that we're going to take to graph both of these equations will be translating the standard form or extracting from the standard form of each equation to find out what the slope and y-intercept are. And so from that, we will know what type of solutions that we plan on having, and we'll also use the interpretation of the slope and the y-intercept to plot other points on the graph. So I'm going to do this through example. So we'll take the first equation here, and I'll write this in blue, will be for x plus y equals -1. So here, if we notice again for the standard form, that slope is minus a over b, and y-intercept is c over b. So for here, we know that both our a and our b will be 1, and our c will be -1. Okay, so let's go ahead and write that. A is 1, b is 1, c is -1. So our slope here would be a -1 divided by 1, which is a -1. And our y-intercept will be c, which is a -1 divided by 1, which is a -1. So here, in noting that, the y-intercept is telling us that we have a point 0, -1 on our graph. Okay, and of course our slope here is telling us something about how we can move from one point that we know on the graph to the other. And so in particular, I'm going to come down here and express this. Our slope is saying that if we know a point on the graph, one of the ways that we can find another point is to move -1 units in the y direction. So we know that the y values or y-axis moves vertically. So this means we have to move down 1 unit. And then this one here down in the denominator, we know that that's the change in x values with the formula for the slope. So we need to move plus 1 unit in the positive x direction. So that means we would move to the right. So we could find out another point on the graph by going down 1 unit into the right 1 unit. Now, of course, since this is negative, we could also write it this way and find another point by going up 1 unit into the left. Okay, so our point 0, -1 is the one that we know of, so we'll go ahead and plot that point. And then from there, we'll follow our slope here using this way and go down 1 unit into the right. So if we go down 1 unit from here, so down 1 into the right 1, we have this point. And then we go down 1 unit and over again, we have another point. Down 1 again, down and over 1 again, down and over 1 again. Now, of course, you don't have to draw this many points. You only really need 2 to draw an equation of a line. I'm just doing this to be more clear. If we use this form of the slope, then this tells us to go up 1 unit into the left 1. So we go up into the left again 1, up into the left again 1, up into the left again 1. And so we kind of see what this particular line is going to look like here. So here, what we'll do is go ahead and draw a line through all of those points. And I'm going to see if I can do that very steady. Okay, so we'll come up here. All right, so that's what our first line looks like. So now we're going to do the same thing, but do it with the second line. And so we'll do the same thing as extracting out what the slope and y-intercept is from this particular equation, and then use the y-intercept and the slope to be able to find other points on the graph. Okay, so now that we have that cleared, we know that -2 plus 3y equals 27. We know that our -2 here is going to be our value for A, our 3 is going to be our value for B, and 27 is going to be our value for C. So our slope is minus A over B. So minus a -2, because remember A is negative, and divide that by B, which is 3. So we have 2/3 as our slope. For our y-intercept, we have C divided by B, which is 27 divided by 3, which gives us 9. And so this translates to us that we have a point 0.09 on our graph. So we'll go ahead and find out where that point is. So here, go up 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. So right along here, okay? So if we keep on looking here, we know that we have a slope, and our slope tells us in this current form that we could go up 2 units and to the right 3 units to find another point. But as you see here, we're kind of running out of room on our Cartesian plane. So what we could do to translate this equivalently is say -2 divided by -3, which tells us we can go down 1 unit and to the left to find another point. And so we do have some points there. So starting from the point 0.9, we'll go down 2 and to the left 3. So down 2 to the left 3. And then we'll do it again. Down 2 to the left 3. And you see this is where our red line and our blue line is going to be crossing here. And we'll do one more. Down 2 to the left 3. Okay? So now when we draw that line, we see that we're crossing, both of these lines are intersecting at this point here. And I'll go ahead and draw this up some more. And now what we need to do is locate what this particular point is. So if we count from the origin, we'll see that we have -1, -2, -3, -4, -5, -6 in the x direction. And then from here we go 1, 2, 3, 4, 5 in the y direction. So the solution to this system would be at the point -6, 5. Or put in algebraic terms, x is -6, y is 5. So now let's move on to our next example. All right, so for our next example, we see that we have another system of linear equations where the first equation is 1/2 x plus 1/3 y equals 3. And the second one is 1/4 x minus 2/3 y equals -1. And so you see here, these look a little nasty because they have fractions in them. Well, one of the things that we can do, fortunately, since we have an equation here, is we can get rid of these fractions and look at an equivalent form of system of equations. And so what we're going to do is take each equation and look at its denominators, figure out what the LCD of those denominators are, and then from that point, we will multiply both sides of the equation by the LCD to clear out our fractions. And then we'll be looking at it in an equivalent way. So let's go ahead and figure out what the equivalent equations would look like, and then we'll do like how we did in the example number 1, where we found the slope and the y-intercept and used that to plot points. All right, so for our first equation here, we have 1/2 x plus 1/3 y equals 3. And so if we look at 2 and 3, the lowest common denominator between 2 and 3 is 6. So if we multiply both sides of our equation here by 6, then when we distribute, we know that 6 times 1/2 is 3. And we carry the x over, and we know 6 times 1/3, or put another way, 6 divided by 3 is 2. And then we carry our y, and of course 3 times 6 is 18. So when we write this equivalent system here, instead of writing 1/2 x plus 1/3 y equals 3, we're going to write 3x plus 2y equals 18. All right, the next one that we're going to do is 1/4 x minus 2/3 y equals -1. And so if we look at 4 and 3, we know that the LCD for that is 12. So we'll multiply both sides of our equation by 12. 12 times 1/4 x is going to be 3x, because 12 times 1/4 is the same as saying 12 divided by 4, which is 3. So I have an x there. We distribute to our second term, we see that we have, and I'll go ahead and write this one out since we don't have a 1 on top. We have 12, make that subtraction, 12 times 2/3 y. And of course on the right side, that's just a -12. Here when we do 12, this is like 12 over 1, and of course 3 would go into 12 4 times. And 4 times 2 is 8. So we have 3x minus 8y equals -12. So we're here now. Alright, so now that we have this, this is in a more simple form for us to go ahead and figure out what the slope and y-intercepts are so we can start plotting points. So let's go ahead and clear with our previous work so that we can start looking for the slopes and y-intercepts of these points. Okay, so now that we have that clear, let's go ahead and start working on the slopes and y-intercepts so that we can plot. So for our first equation here, we are going to write in red, and here we know that the slope is going to be minus a over b. So we know a is 3, b is 2, c is 18. So we have a minus 3 divided by 2. So that's what our slope is. And so we can interpret this as being -3 divided by 2, or 3 divided by -2. And of course that's important to us because -3 tells us to go down 3 units, and 2 tells us to go to the right 2 units to find another point. +3 tells us to go up 3 units, and -2 in the denominator tells us to go to the left 2 units to find a point. Now the corresponding y-intercept for this will be c over b, or 18 divided by 2. And of course 18 divided by 2 is 9. So for our first graph here, we'll see that we have our y-intercept is at the point 0, 9. So we'll go ahead and find that. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we'll put our point here. And then we can go in either direction and find some points. And so I'll start with going down 3 units into the right 2 units. So we go down 3 from here, 1, 2, 3, and then to the right, 1, 2, found the point. Then go down 3, 1, 2, 3, to the right 2, 1, 2, 3, to the right 2. And then we can do the same thing in the other direction. We can go up 3 now, and then to the left 2. So up 3 and to the left 2. And then, of course, we're running out of room here, so we don't want to go anymore. So I'll go ahead and do one more down here. Down 3 and to the right 2. So this is what point on that particular line looks like. And from that, we get a feel for what the line will actually look like. So we'll go ahead and draw the line now. Okay. So our line looks something like this. So now from here, we'll go ahead and do our work for the next equation in blue. Slope is minus a over b, which is a negative, and then a is 3 divided by b, which is a negative 8. So we have positive 3/8 as the slope. And so remember, we can either interpret it this way as going up 3 units and to the right 8 units, or we can go down 3 units and to the left 8 units. Find our y-intercept. We just do c divided by b, and c in this case is going to be a negative 12, and b is going to be a negative 8. And so from here, what we'll get is, when we simplify, positive 12 over 8, which is the same as 4 times 3, 4 times 2, which simplifies to 3 over 2. Of course, that reduces to 1, and we can also think of it as negative 3 divided by negative 2. Where here we go up 3 units to the right 2. Here we go down 3 units to the left 2. So we're going to start at our y-intercept, which is 3/2 or 1.5. So 1.5 is about right here. And so from here, we're going to go, I guess, up 3 units and to the right 2. So we'll go up 3 units, 1, 2, 3, and to the right 2. And then we'll go up 3 units again, 1, 2, 3, and to the right 2. And you can see from there, we kind of have an idea of where this is going to cross. So all we need to do now is connect our line. And so here at this particular point here is approximately where it would cross. So this will conclude our initial examples on how to solve a system of linear equations by graphing.